Okay, this is a question about conic dissections. This is hyperbolas. It's a real world problem. Example 3, page 584. And it talks about ships and navigation systems and a specific system called Loran, which basically stands for long range navigation. Okay. Now what it does is it calculates the difference between the arrival times of simultaneously broadcasting signals. That means it fires a radar, basically some radio waves from here, and they both bounce off of ship, and they should be able to tell. They take the difference of the times that the radar takes to ping back off of that ship, and then they calculate the difference, and they can see how, they can see the exact positioning of the ship. The information told us here, all points on the hyperbola number 25800. Now that's just this hyperbola here. It's just a piece of data that they've collected. All points in that hyperbola are shown in the diagram are 48 miles closer to one transmitter than another. The transmitters are the foci. So here's a transmitter, here's another transmitter. They're 200 miles apart. So this is going to be 200. So obviously that coordinate point there is going to be 100, 0. We're basically asked to find the equation of the hyperbola. Okay, I'm going to just enlarge that. I'm going to enlarge this image for a second, and I'm going to bring a. Oh, that's not right. That's not right. Here we go. Let's enlarge that, and I'll bring. And I'll put a picture of a hyperbola next to it just so that we know what we're talking about here. So here's a hyperbola. Here's y, here's x. Now this is translated slightly, which means that the axes are slightly over, a little bit like this. Now in a hyperbola, we're talking about, this is the center, which means that this distance here is A, and we've got B coming up here. Now, what the question talks about is that the transmitter, they're firing out these hyperbolic radio waves, and they're firing them out together. And what they're trying to find is the ship that's located. Now, really, what it's saying is that one of the ships, or the ship is figured here, so it's 48 miles closer than the other one. Now, the way the example does it in the book is it talks about finding this distance, which is, let me use some straight lines here. It talks about this distance subtracted from this distance. Okay, and what that basically gives us, if I rearrange it a little bit, and what that basically gives us is this distance in between here. Okay, and we know that that distance is 48 because it told us that it was 48 miles closer. Really, when we look at a hyperbola, we're talking about A and A here, and so basically we know that 2A equals 48. Now the book goes about that in a very long-winded way. It calculates this blue line as being, I think it's A plus 100. And it calculates this little blue one here as being 200 minus A plus 100. It's a quite complicated way, and they find the difference between those two. And if you simplify that, you get 2A equals 48. Well, I prefer my way, which gives us A equals 24. Once we found A, we can figure out what B is. Now B is going to be, what's B going to be in this case? We can use, what do we know? We know C, don't we? Let's extend the page down here. We know that A equals 24 now. We know that C equals 100. So we can use the fact that C squared c squared minus a squared is going to give us b squared. C squared, so 100 squared minus 24 squared is going to give us b squared. We know that b squared, if we add this up, 24 squared, 576, add 10,000, subtract that, we're going to get 9,424 equals b squared. All right. Now, to write an equation, it would be x minus h, which we know is going to be 100, right? That's minus 100, simply because the distance here is 100. Right, that's going to be our center. So it's x minus 100 over a squared, 24 squared. You can write 24 squared or 576, whatever you want. And then subtracted y squared, that's the other coordinate point, that would be 0, so it's y minus 0. Actually, this should be squared. And that's divided by b squared, which we said already was 9424. And that standardized should equal 1. Okay, so that's the equation of the hyperbola. Really, the most difficult part, given the question, the example in the book makes it very complicated to calculate this fact here, but realistic, and they do it this way. But realistically, we can kind of figure out that that's 2a. The distance, the difference between the two ships is twice a, and that's how we figure out the Loran question.